Welcome to our webinar entitled Pervious Concrete, Density is Our Destiny. My name is Eric. I'll be your operator for today's call. At this time, all participants are in a listen-only mode. You may submit an online question at any time using the Q&A feature on your web console. Later, we will conduct a question-and-answer session. Please note this conference is being recorded. I will now turn the call over to Jeremy Montgomery, Executive Director, Nebraska Concrete and Aggregates Association. Mr. Montgomery, you may begin.
All right, well, welcome everyone, and actually welcome to my very first webinar. This is going to be a little strange for me because I have an ability to read faces when I'm getting too technical or getting lost in the weeds, and now that I can't see anybody's faces, this is going to be a little bit interesting for me. But nonetheless, welcome to Pervious Concrete, Density is Our Destiny. Just to give you a little bit of my past history, I started in the mid-90s working for the Department of Roads, breaking cylinders, running specific gravities on cement, and I always like to tell people if I knew I was going to take a career in concrete, I probably would have paid a lot more attention in that lab. But from there, I went to be a concrete contractor. I actually went back to school, got my construction management degree, ran a crew of about 20 guys in the field. Wasn't a finisher, just a construction operations manager, but learned a lot of things in the field like pumpability, finishability, workability, constructability, the things that I didn't know before. And of course, in 2006, I got this job as the executive director for the Nebraska Concrete and Aggregates Association. And one of the things that they had told me when I got hired was you're going to be promoting pervious concrete. And, for all those years of being taught to get good slopes, seal the joints, and now you're going to tell me that we're going to put water right through the pavement, especially in Nebraska where we have a freeze-thaw cycle. I was very skeptical, to say the least. But my impression of pervious concrete in 2006 is a lot different today than it was back then, and it's because of the knowledge that I have today that I didn't quite have in 2006. So what I would like to do is take this presentation and kind of take you what I like to call the Nebraska experience, and everything that I'm going to show you is through my own eyes. A lot of people like to focus on books and manuals and guidelines and specifications, and I really kind of want to take some of that out for today because I really just want to speak on my own personal history of pervious concrete from a guy that's worked in a lab, that's worked in the field, and now has a little bit more of the technical side of concrete. So we're going to go through a little bit of the basics of pervious concrete. We're going to talk about some construction tools, techniques, considerations that we have in the field. And then I'm going to introduce you to what I like to call the Nebraska quality assurance, quality control for pervious concrete. And then, of course, we're going to end it off on some project profiles and case studies of pervious concrete. So let's get this baby going. When it comes to pervious concrete, some of the mixed properties, it has a single-size aggregate. With conventional concrete, we like aggregates to be a uniform distribution of sizes, but this is what we like to call one of those gap-graded mixes. And because of that gap-graded mix, it has an interconnected void structure of, I'd say, somewhere between 15 and 35%. Some books say 15 to 25. But this mix that you're looking at on the screen has no sand. But I do know that talking to my colleagues, if you add about 5% sand to that paste, it actually is a little bit better for freeze-thaw durability climates. I don't know if I can explain why, but we'll get at that in a little bit. But because of that, as mixed design, a lot of people ask me, well, what about strength? And I guess if you take a core of pervious concrete and you put it under a compression machine, you're not going to get the same strength as you would of something like conventional concrete, simply from the fact that we've literally removed 20% of the material out of this core. So even if the paste and the aggregate was durable and strong, you're not going to get the same strengths. About infiltration, I like to see somewhere around 500 to 700 inches per hour for new pavements, and we'll talk about infiltration later. But when it comes to density, there's a difference between what I like to call design density or fresh density, and there's a difference between hardened density. For me, at 20% void content for my mix, I like to see about 125 pounds per cubic foot, and at a hardened structure, about 119 pounds per cubic foot. Why do those two numbers not match up? Because one is fresh with a lot of moisture, one is hardened, and we're losing moisture through hydration, through evaporation. So even at the same void content, you're going to have a different unit weight or density between a fresh and a hardened specimen, given the same void contents. And we'll talk about that here in a little bit. All right, so why is density so important to understand? Well, if you can control fresh density, you can control strength, infiltration, and in my own personal opinion, durability. So in about 2007, I'm sitting in the audience and I'm listening to a guy by the name of Bruce Ferguson. Bruce Ferguson actually wrote the book on porous pavements back in 2005, and he's standing there, and I remember this slide very vividly, where he says pervious concrete is a balance between hydrological and structural properties. And I sat there and I thought for a second, and I said, well, it's a real fine line there, and what he's saying is you want the pavement designed to be able to have water go through it, but not so much that you're going to lose the structural properties that are going to hold up traffic, be durable to turning tires, freeze thaw, all those different things. So I think if Bruce and I were to meet today, I think what he was trying to say was density is our destiny. And I know that's a nice little catchphrase, but I really believe that density has a lot to do with the future of our market in pervious concrete. And as I talk to contractors here today, one of the biggest things I feel that is important that you understand what you're accepting when that truck delivers. And how do we understand what we accept and what we reject as far as the fresh properties go. So pervious concrete isn't just a pavement. It's a stormwater management system. We use it in parking lots. We use it in sidewalks, trails, driveways, even behind retaining walls, all sorts of different applications. One of the main ones, though, is parking lots because, of course, it has the most square foot of impermeable surface, which takes all that rain and goes to the storm sewers. So what we're trying to do is treat it and retain that storm water on site by using it in something like parking lots. I'm going to show this nice little video, and I'm going to actually play it twice. First time I want you to take a look at it because I know a lot of you out there have this vision and you've seen this YouTube video of a guy with a bucket of water and he pours it right on the pervious concrete and it goes straight through. Now I really think that's kind of screwed our industry because now this is what owners think permeable pavement should be. Almost like a drain. It should go right through it. But I'd like to take that myth and challenge it a little bit. And here in Nebraska, what we like to do is sacrifice infiltration for density. We're going to get our pavements a little bit more dense, and we're going to sacrifice that infiltration. So when we build our pavement, go ahead, and here's the water. I'm going to pour it on there. And what I like to see is it dispersing and then kind of soaking into the surface. And I know because we did an ASTM infiltration test at this location, and it measured about 300 inches an hour. But with that bucket going straight through the pavement, I guarantee you that's plus 1,000, maybe even 2,000 inches per hour. And I just don't think that those pavements with that kind of infiltration are going to be durable and withstand turning tires, freeze-thaw cycles, and all that other good stuff. So we've made a conscious decision to sacrifice infiltration for a little bit more of a dense pavement. And again, I'll show you this one more time. And I really would have loved to show you guys a lot of videos, but I know with these webinars that gets a little bit tricky and sometimes may blow up in my face. So this is the only video I'm actually showing today, and I wish I could show more, but nonetheless. So again, we're sacrificing infiltration for dense, durable surfaces. So if we can go back to the presentation, we'll go to our next slide. Now, this is where I'm going to start that Nebraska experience. This project that you're looking at here, this was 2009. And the books used to say that you used to be able to grab this pervious, mold it into a ball, and it shouldn't deform under its own weight. And if you look at your hand, you should have about a 50% paste to skin ratio. Real technical, high-tech type stuff for a visual inspection. And you can tell that's me in the back with the sunglasses on my bald head. I now know that I look like some type of tourist that got lost on a construction project. But the guy to my left in the white hard hat is Mike Willman of W.R. Grace. And I think one of the things as you look at the looks on our face, it's definitely the look of uncertainty. It just didn't seem right with me, and it didn't seem right with Mike. And I know now that that mix is absolutely way too dry. And let me explain here in a little bit. On our next slide, I call this the meatball versus modern Pervious. And I have to put a disclaimer out there, so if you're under 18 years old, you might want to cover your eyes, cover your ears, because this is straight up concrete porn. If you look to the picture on the right, where you have, it looks dry, it looks unhydrated, rough, weak, you know, maybe that's what you're into, but what I like to see in my Pervious concrete is something that's smooth. The curves, if you notice the picture on the bottom right, it looks strong, it looks hydrated. I mean, that is definitely the biggest difference I've seen in Pervious concrete is this meatball versus modern Pervious. I mean, when we used to mix up and produce a batch of Pervious concrete, we were very nervous as producers to get it too wet because we thought, well, maybe that paste was going to run off the aggregate and clog the system. But what we know now is we need that hydration of that moisture to make that paste strong, that binds those aggregates together. And on that big picture there, that's actually a picture of a core I brought home from the testing lab, and I have it actually under the sink of my kitchen. And my wife walks in, and she's like, "What the heck are you doing?" You know, and I'm looking for different things and clues, and I'm looking at that paste. Is it smooth? Is it the bond between the aggregates? You know, do I have this concave feature that's bonding the aggregates together? And that's an indication that I have good moisture, good hydration, which means a good glue holding all these aggregates together. All right, so that's enough about the mix. If you're under 18 years of age, you can open your eyes now. We're back on track. But what I'd like to talk now is about some construction techniques, some tools and the considerations that we take into consideration during the construction of these Pervious concrete pavements. And if you don't have any experience with placing Pervious concrete, you're soon going to learn that it's much like conventional concrete. I mean, you still have to place it. You still got to strike it off. You still got to finish it. Yes, I said finish it. Still got to cure it. Some of you may or may not know what curing concrete means. I'm a big cure guy. And of course, we still got to join it and cut it. And so one of the things that I did leave out of that whole placement that's kind of like conventional is consolidation. We can't vibrate anything because then definitely we're going to get some clogged pores and the pavement may not be able to drain. So everything that we do with Pervious is usually by weights or rollers, and I'll show you some of those tools here in a second. When we talk about sub-base, subgrade, I try not to be too much of an expert on this because I'm not a soils guy, I'm not a sub-base guy, but what I do know about this is in Nebraska we use about an 18-inch rock base. And this rock base is kind of like your 57 stone. It has about 40% voids in it, and that 40% voids is storage area for stormwater before it has time to percolate back into the soils or go to an outlet. But this sub-base, one thing that I've learned is it has to be uniform. It doesn't have to be strong, just a lot like conventional concrete pavements. We don't need strength in our sub-base, but we do need uniform strength. And so 18 inches seems to work well for us. We started with about 12 inches. It seems because of the frost depth and stuff that just wasn't quite deep enough. And 18 inches seems to be the minimum depth that we use for our sub-base subgrade. On this next picture, I want to show and talk a little bit about the placement procedures. Yes, of course, you can put it out of the back of a chute, but it takes a little bit more time. The more chutes you add to the truck, the less of an angle you have coming out of the truck, and therefore the more slower it's going to come out. I can tell you on this project, that guy in the yellow hard hat that's running the chute literally probably pushed 100 yards of pervious concrete out of that chute. So it can be done, although it's not one of my favorite placements of pervious concrete. The other thing I don't like, if you look at this picture, I don't like those truck axles right on the edge of the conventional concrete. Really think that's putting a lot of stress and strain on that, and could lead to some mid-panel cracking due to loads. But we've also driven the trucks right on the sub base also, and done it out of the back of the truck as well. My favorite placement method is with a conveyor. Of course, it's easy for me to say that. I'm not paying for the tab, but I've noticed our production has gone up when we use a telebelt because you're not worried about getting trucks in and out. As soon as one truck is done, the other one backs up and we're ready to go again. The other thing I like about a conveyor is it actually is dropping it down about 15 feet. And that's getting a little bit more compaction, a little bit more of a dense material being put down versus out of the back of a truck where you're literally just pushing it down the chute and almost laying it down. When it comes to another placement, this is kind of a funny story because I attended this pre-con meeting where this contractor, I say, well, I prefer a conveyor. And he goes, oh yeah, we got one of those. And I showed up the next morning when we were going to place the pervious, and he has this, what he calls it, I think it was an MFT placer, or MTP placer. It had an auger in the back. It was something I was completely unfamiliar with. It made me very nervous. But lo and behold, it actually was a very good way to place that pervious concrete, and worked out like a champ. Some of the methods of striking pervious off, of course, we can't use vibration, so everything we got to use is usually roller screeds. This is one of the first pieces of equipment we used in Nebraska called the power screed. It actually has 3 rollers on it, 2 rollers that sit on top of the forms, and the third roller, which is in the front of the screed, that's usually raised up 3/8 of an inch or so to knock everything down, and then the other 2 rollers literally compact by weight the surface of that pervious concrete. One thing that you should notice here as well is with all the pictures that I'm probably showing today is the location of that plastic, that curing membrane that we're using right behind strike off. Because this stuff has such a low water cement ratio, we have got to maintain moisture in the paste, especially at the surface of the concrete, to make it strong and durable. But that's the what we call the power screed. Probably the most popular tool to strike off pervious is the single roller screed. It's a 6-inch tube, usually hydraulic, or I've seen some of them that are gas powered. You know, this roller as it goes, it's trying to get away from me and you're pulling it back. I kind of like this picture where these guys used tie downs to use them around their waist to help them pull, because I've always said if you're going to have 2 guys pulling a 20-foot long or 20-foot wide strip of pervious, you want your 2 big boys on those ends, because it'll wear your hands down by the end of the day. But again, look where the plastic is. It's only 10 feet back from strike off. We're maintaining that moisture the best that we can. And I wanted to put a little bit of something in there about edge work. We can edge it. I've edged it with a 1/2-inch edger. You need these mixes to be a little bit smaller with the aggregate size. And one of the things that I try to communicate to these crews is if the pervious concrete mix is sitting in the curb, don't put it back in the mix. Once it's out, it's out. I always bring back shovels of a little bit of fresh pervious to work that edge. But once it's out of the edge, don't ever put it back in. It just seems like those edges end up being dry and end up raveling. But you can edge it with a 1/2-inch edger, but our mixes are about that 3/8 minus, which is a lot of 1/4-inch aggregate. I think when you start getting into the 1/2-inch aggregate, then it's really tough to put a nice 1/2-inch radius edge on that. But again, I do like to edge it. I got a lot of people that tell me that they don't edge, but I disagree with that. I think if we can put an edge on it, let's put a radius edge on it. Cross rolling, this is a tool that we use that's typical with, I call it the bowl float of the pervious concrete world. When we first started cross rolling, we would do it to remove the lines of the roller screed, and we did it before the plastic was down so we can see everything. But these mixes the mixes that I've used are pretty sticky mixes, so they have a tendency to stick to the tools and whatnot. So a lot of the cross rolling that we do now are cross rolling right on top of the plastic, which seems to work really well. One of the side effects of this is the guy running that cross roller really has to ensure that he's doing everything he can to cover every square foot of this, because you can't see your roller lines. You just got to make sure you're being consistent with that roller going down the line. But again, look at where that plastic is, right behind the roller. Just doing an excellent job maintaining moisture. Curing. Now, if we were talking about conventional concrete, I'd have to go on a whole new hour webinar on why it's important to cure concrete. I'm just a big advocate of it. I think it's one of the basic fundamentals of placing even conventional concrete is maintaining moisture and maintaining temperature. Now, when you're talking about pervious concrete, you know, our mixes have around that 3:5 water cement ratio, so it's extremely low. If I want that paste to be a strong glue that holds these aggregates together, I have got to maintain that moisture at the surface, or moisture throughout the mix, not just the surface. But one of the things that we do in our pre-construction meetings is we discuss how are we going to hold this plastic down for 7 days. Because 7 days is a long time here in Nebraska. It's pretty windy. So we got to make sure that we're doing everything that we can to hold this plastic down to make sure that it's not going to blow around and dry out the surface of our pervious concrete. What I expect now from my crews, that I should say the crews that allow me to come in and guide them, is that I require a mechanical fasten of this plastic. Because it's extreme, even with sandbags, it becomes extremely challenging to keep that plastic from acting like a parachute. So here's in the last few projects that we've done, we actually came back before we were done placing and mechanically fastened that plastic down to the what he's doing here is a header curb, but the integral curb, header curb, wherever you got to fasten it down to, let's make sure we're keeping it down for 7 days. Joining. Now, this little tool here is my arch enemy. I do not like the joiner. This is what we call the groover or the pizza cutter. We were using this to hand groove our joints in pervious concrete, I would say probably 2006 and 2007. And again, we just haven't had the durability out of these joints using this joiner like we do with a saw cut. But back in 2006, 2007, I had a lot of people doubt whether or not you could actually saw cut pervious. But since 2007, we've actually done a great job with saw cutting pervious. The question becomes, at what time do you cut the pervious? Because remember, we've got that plastic down. We want to hold that plastic down for 7 days, not let the surface dry out. So do you come in a couple days later, uncover it, then cut? Some of these times we've actually waited 7 days before we cut, but it was a little cooler outside and we thought we can get away with that. Another thing that you see in this photo is something very unique, is the sealant. I used to have a picture where I did these box lunches. I used to make fun of this picture, pervious concrete with sealed joints. I just thought it was the most funniest thing, most biggest waste of money I've ever seen. But there's two reasons why we seal joints. One is to keep out moisture, which is ridiculous for pervious concrete. And the second reason is to keep out any kind of incompressibles. And especially with pervious concrete, as you take that saw blade down there, you're going to have thousands of little rocks that are just kind of hanging on there. And you don't want those falling down, thermal expansion, thermal contraction, just eating away at that joint. So our detail now is to saw cut and to seal the joints. And I will tell you that it is a night and day difference from grooving those tool joints to saw cutting and sealing them. Just a dramatic difference in durability. Now, in the defense of the groover, this was still back when we were still using very dry mixes. What I hear nowadays is people using the wet mixes and using a 3 mil plastic that goes over the top and grooving it over the top of the plastic. And it seems to be working real good. I would like to use the groover on some of the mixes that we've developed recently because they're a lot more workable and probably be a lot more durable today than I give them credit for in 2007. Make sense? All right, let's talk about some ASTM's testing standards, because when I started in '06 with this stuff, there was no ASTM testing standards. Remember that little picture I showed you that they were mixing up, hang on here, this phone's going to kill me. But in 2006 what we did was everything was by the eye. We were mixing these things up like softballs. We were looking for that 50% ratio of paste to skin on your hand. It was just literally a nightmare because nobody really knew what they were looking at least not in our region. And then in 2008, ASTM C1688 came into play, which is the standard test method for density and void content of freshly mixed Pervious. And I'm going to show you a picture and explain this in a little bit. And then I believe it was 2009, ASTM C1701 was published and released, and ASTM 1701 is how we test for infiltration of in-place pervious concrete. And then I believe it was 2011, 1747 came on, and that was a really interesting test of the potential resistance of degradation of pervious concrete by impact and abrasion. I got a really cool picture of this. It looks like a popcorn ball when we're all said and done. And then, of course, the last one, which I believe came out in 2012, one of my favorites, ASTM 1754, which is actually, after you extract the core, we can test for hardened unit weight and void content of that core. Here's a photo of ASTM C1688. So you can notice that you recognize that little air pot. It's a 1/4 cubic foot. You fill it up halfway. You give it 20 blows with this hammer, which is a standard Proctor hammer. You fill it up another half lift. You give it another 20 blows. You strike it off, and you weigh it. And it gives you something called unit weight or density in pounds per cubic foot. It will also calculate void content. But is this telling us what we're placing in the field? And my answer is no. It is not testing the density of what we have in place or the void content of what we have in place. It's only telling you the density or the unit weight per the standard. So per the standard meaning 2 lifts, 20 blows per lift, striking off, weighing it. It is not a representation of what we're putting in place, just per the standard. Here is a picture of ASTM 1701, the old infamous infiltration test. This is a test. It's a 12-inch ring. You do a pre-test, depending on how fast it infiltrates on your pre-test, then dictates how much water you use on the actual test. We've done a number of these. I really like to see somewhere in the range of 250 inches an hour all the way to 750 inches an hour. I think when we start getting higher than 750 or 1,000 inches an hour, we're just talking about a very high void content slab, which is great for hydrological purposes but may not be so good for structural purposes. So there you go with ASTM 1701. Something else with this 1701 test, a lot of people don't understand that it is not a test for acceptance. So let's say we ran this test and it showed 50 inches an hour. Do we accept or reject based on this test? No, we don't. We use it as information. What we do here in Nebraska is for every 5,000 square feet, we'll go do 3 of these infiltration tests on a brand new slab. We'll document where we did that in the slab. And then so 3, 4, or 5 years down the road, we can actually do the same test in the same location to understand how much infiltration we've lost, when is maintenance going to be needed, and so forth. So we use it for information purposes, not for acceptance. ASTM 1747 right here is looks like a popcorn ball. We've ran this test twice with our mix, our basic mix, which is just rock cement and water and some admixtures. But again, this is not an acceptance test. We've ran 2 of these tests. As a matter of fact, I have Terracon right now with my 3rd set of specimens to run this test. And basically you take 3 specimens that are 4 inches tall at exactly 20% void content. You tumble them in an LA abrasion machine, and you really just beat the snot out of them until you go through 500 revolutions. You measure mass loss, and our specimens have about 35% mass loss. And everybody goes, well, Jeremy, that's an awful lot of mass loss there. That can't be a good mix. Well, in the future, when we start adding fly ash, when we start adding fibers, when we start adding silica fume and all these other types of value-added products, we'll be able to do this test again to see how much tougher those value-added products are to this mix. Think of our mix right now as just the basic standard mix, and it can always be improved on, but we're not quite there yet. But this test is not for acceptance. It's just more for information of, to me, telling me how tough my mix is. And then, of course, another disclaimer for anybody under the age of 18. Again, close your eyes. This is more concrete porn. Matter of fact, if this was in a magazine, it would absolutely be the centerfold. Matter of fact, I have this poster on my wall of this exact picture because I call this the money shot. It's ASTM C1754, testing the hardened density and the hardened void content of pervious concrete in its hardened state. And this is one of the things where Nebraska, I take a lot of pride in. We are one of the only ones, I feel like we are one of the only ones that can prove we are predicting in-place void content. If you want 20% void content, we can place 20% void content given tolerances, pluses and minuses, but we can hit it pretty good, and I'm going to explain that in my quality control segment. But again, ASTM 1754, only a few years old, so we need more people out there that are running these tests so we can get those ASTM committees some information on how we're doing in the field. So a lot of people also ask me, well, Jeremy, how do you what do we accept pervious concrete when that truck shows up? Well, in accordance with ACI 522.1-13, meaning it came out in 2013, relatively new update to the specification. And just so some of you know, I actually do sit on this 522 committee. And when I tell people, when they ask me for specifications, I always direct them to ACI 522 because it's just a group of people that sat in a room for years, literally years, and argued about every little word, every little tolerance, every topic that are in these. And it's from the industry of academia, from contractors to producers, all coming together to create a specification, and you just can't get any better than that. Being that said, I still have designers that create their own specifications that may or may not fit the project, but to me, I'm always trying to push this ACI 522. And in accordance with ACI 522, for acceptance, you have to do a mock-up. And we have to core that mock-up, and we have to have the engineer accept some certain values. And this is where I get these concrete contractors that call me up. I just had one recently that called me up and said, do we really need to do this mock-up? And I said, yes, if you're the concrete contractor or the concrete producer, you should be pushing for this mock-up because it's the only thing where somebody else is going to accept some values, and that's what you try to hit. That way, in the future, if anything went wrong, you adhered to these specifications and you reduced your risk, if that makes any sense. With that being said, it says right there in 15.4, the fresh density of the test panel should be within plus or minus 5 pounds per cubic foot of the accepted fresh density from the submitted mixture proportions. Now this is what, to me, what is accepted fresh density? Is that the design density? Because if it is the design density, I'm going to say that that is not necessarily true, at least not with the data that I've collected, and I'll get into that here in a little bit. But once we do that mock-up and we sit down and we talk about the unit weights, that's accepted, what our tolerances are. When we actually do the project, we have plus or minus 5 pounds from that value, and then on the after we core it, we have plus or minus 5%, which is different than 5 pounds. It's actually more like plus or minus 6 pounds of the accepted hardened density, which in all my projects that I've done, there was only one we really came close to not meeting. The rest of them are, it's actually, I think, pretty easy to hit these targets. So our QA/QC program here in Nebraska is a little bit different. I actually require a lot more than what ACI 522 requires. If I can get my foot in the door soon enough, I require a pre-bid meeting, and I sit in with 5 or 6 contractors that are bidding on the project, and we talk about, how are we going to hold the plastic down? How are we going to place it? Maybe you should bid it with a telebelt. Maybe everybody should bid it with a telebelt in it, because I think it's just going to be a little bit easier to place, your production better, and I think you're going to actually end up saving money when it's all said and done. But in the pre-bid, we also talk about 522 and what the responsibility is of everyone. We also talk about the importance of curing and keeping that in there. And actually, I probably have these two mixed up. I probably should go pre-bid, then the mock-up, then the pre-con meeting to talk about all the tolerances and the unit weights that we need to achieve in the field. And then per 522 specification, it only requires 1 fresh unit weight test per placement. And we test every single truck. And I know to do this because a lot of you guys know when you're ordering a conventional concrete and you want a 5-inch slump, you can kind of tell what that 5-inch slump looks like because you've seen it over and over and over again. If I'm trying to hit a unit weight of 130 pounds per cubic foot, nobody knows what that looks like. So you have to run the tests on every truck to build confidence in what you're actually accepting as a contractor. And then once the project's done, we go in, we take 3 cores for every 5,000 square feet. We do 3 infiltration tests, the 1701 tests, for every 5,000 square feet. And then when it's all said and done, I require a post-placement meeting where I get everybody back in the room and we talk about what we used for acceptance. Did we hit our numbers? What were the hardened void contents? What were the hardened infiltration tests? So that everybody learns a little bit. What I hate going through is going through all this dog and pony show and then nobody learn anything at the end of the day. So I do require a post-placement meeting just to ensure that everybody learned a little bit. This also is an excellent picture. I just got done telling you that every time that truck shows up, we do a unit weight density test per ASTM 1688. And then I take that weight and I go to the curb and I write that weight down right on that curb, somewhere where the middle of the load is. I'm not getting too scientific, but about the middle of that load, I'll write down what the fresh unit weight was, or fresh density, and then when we go core that, we can refer back to what the fresh density is so that we have excellent correlation between fresh density and hardened density because, again, they're going to weigh different even at the same void content. All right, let's get into some projects, probably what you guys have probably been waiting for this entire time anyway. Metropolitan Community College, we started this in 2009. There was 3 strips of parking stalls, probably a little over 3,000 square feet. The designer was HDR, which is a national firm, big one for us. There was a lot of eyes on it. And this, we actually failed the mock-up twice. I'm not quite sure how the designers actually let us proceed forward. But this is one of the first projects in Nebraska where we actually tried to predict in-place void content. And here's that picture again that you've seen earlier with the plastic right behind the screed. You've got sandbags holding the plastic down. One thing I don't like in this picture is seeing the workers trample all over the pervious concrete, but it's neither here nor there. But Metropolitan Community College, again, every truck was tested for fresh unit weight. We marked it on the curbs. When we cored, we referred back to that curb. And I can tell you right now, our goal, sitting in front of this meeting, in front of the designers, in front of the owners and the contractors, I said, we're going to hit between 15 and 20%. At this time, I really didn't know what was going on. I just knew I wanted a dense pavement. I was tired of seeing all these real open, high infiltration slabs. I said, we're going to shoot for 15 to 20. And then we had our design density on paper, 125 pounds. Our target density on the 1688 was 133 pounds, which is about 14% voids. And again, that's 2 lifts, 20 blows per lift, striking it off and weighing it. That's not telling you what you're placing. I assumed we were going to gain voids from, we're not going out in the field and giving that 6-inch slab 40 blows and 20 blows per lift. So I assume we're going to gain voids. But we didn't know at this time if that was really true or not. After it was all said and done, the average hardened density, which I don't have the pounds per cubic foot, but I do have the void content, was 16.7% voids. There was one core in there that was down to 12%, which is hardly almost conventional. And there was one in there that was around 21%, but it averaged out of 6 cores 16.7%. And had a pretty good infiltration rate. I know there was a couple in there that was 1,000 that kind of skewed our number a little bit on the high end, but 743 is the average of the 6 infiltration tests. Moved on to Sarpy County Sheriff's Department. Funny story here. This old boy, I showed up and he had one of those Texas screeds. I think you guys call them Texas screeds. I call it a truss screed. But he had one of those with the roller screed, and he was going to strike it off with the Texas screed and then come back with the roller. And I said, get that truss screed out of here. You don't even need it. Of course, he's saying, well, that's not what I saw on the internet, and that old joke. Every time I see that commercial of it's got to be true because you heard it on the internet, I think of this old boy. But we went round and round and exchanged some words, and good thing his truss screed didn't even start up. It couldn't get it fired up, and had to use the roller screed, and it was all good. And by the time we were all said and done, we were hugging and kissing each other, so we were all happy. But I didn't get to have a pre-con, a pre-bid. I heard about this project literally 2 days before it went down, so we didn't get everything that we wanted. But it's still, we got to run unit weight tests. We got to run 3 cores from the slab, and we ended up with 25% voids. And that's pretty high voids considering that we were averaging 15% voids or 130 pounds on the fresh density. So what I look at is we gained 10% voids from the 1688 test to in place. And that struck me as I was imagining more like 20% instead of 25, 26. But we didn't place this with a conveyor either. It was straight out of the back of the truck. So we weren't getting any compaction from the pervious concrete dropping 15 feet in the air. Average infiltration, 239 inches per hour. And lots of numbers here, lots of data, but I'm just trying to show you guys that when we do a pervious project, it's all hands on deck. And we're trying to collect every piece of information that we possibly can to help us make better decisions on the next project. So here's UNL parking garage. It's a mix with some pea gravel, with some pipe rock in there, a little bit larger aggregate than what we were used to with the first few projects. One thing I want to stop here and look at that header curb going right down the middle of this slab. We do that because, and I used to get a lot of slack for this because it was added cost, but we're saving money because I can place one strip on in the morning and just jump right next to it when we're done and do the next strip next to it. So just by spending a little money in that header curb, we're able to place something that's more than 20 foot wide, because that's the only width I would recommend pulling on that roller screed is 20 foot wide. So we break that up with a header curb. But again, this project ended up with, we averaged 131 pounds, or about 15%. And on the hardened density, again, we didn't have the ASTM hardened density test yet, so all I was getting was void contents, and we averaged 21% void. So we gained 6% voids from the 1688 test to in place and averaged 650 inches an hour, which is great. Then Southeast Precinct came along, and up to this point, I started realizing that all my producers were using different mixes. So was all the data the same, or was it all different? What did it all mean? So I developed a baseline mix on my own, which is basically 500 pounds of cement, 2,700 pounds of rock, and a 3:5 water cement ratio, with some admixtures in there to to make it all work. But on this Southeast Precinct project, we started this mix, what I call a lean mix at 500 pounds, and took the 17,000 square foot parking lot and extracted 21 cores, because I knew we were onto something as far as being able to predict in-place void content. And if I'm trying to hit 20%, my goal is how close can I get to that 20%, and how many times can I do that? So out of these 21 cores, you can see at the bottom, we averaged a fresh unit weight on that 1688 test, about 130 pounds, and we ended up at 21% voids, which was about 118.5 pounds. So right now I can tell you, before I even mock up, my dry or my hardened unit weight is about 119.5 pounds per cubic foot. That's what I'm trying to achieve in the mock-up and in place. Is that so? And you can even see here we averaged at 4.8% voids from the 1688 to in place. So now we are literally being able to predict an in-place void content utilizing fresh unit weight. Terrell Park. This is an interesting one. Look at that plastic, man. That's a beautiful picture. All them sandbags, keeping that plastic down, retaining that moisture. And this is an interesting project because it's literally across the street from a middle school that both of my kids, well, one attends now, the other one will attend in a couple of years. But I told the contractor, I said, do not screw this one up. I have to see this every day. I literally come down this street and turn around in this parking lot during the school year every morning. So I'm able to analyze and see what it's doing. Here one morning, it was raining real hard, so I took a nice little picture. Again, notice those header curbs. This was 60 feet wide. We broke it up into thirds, used those header curbs, and we poured the whole dang thing in one shot. But as far as the densities, again, average fresh density, 129.9, that was our target, and we averaged about 26% in place, which seems a little bit high to me, but again, doing it out of the back of a truck. You're gaining about 10% voids. 50th and Pine, one of my favorites. In the picture on the left, you'll see that kind of rusted cover in that pavement. There's lots of sensors underneath this pavement, and you can actually go to the website to determine how full the reservoir is getting and the temperatures. It doesn't monitor pollution by any means, but it does monitor some other things. I wish my colleagues in Omaha would tell me how to get to this website and use it so I can promote it a little bit better. But again, header curb right down the middle, poured the whole thing in one shot. And some of the tests that we had on this one, again, we're using the same mix that we started off with Southeast Precinct. 130 pounds we averaged on the fresh density, ended up at 119 pounds or 21.9% in place. So again, I'm trying to hit around that 119, 120 pounds in place. I know that just because of all the data we've collected. I don't really even need a mock-up anymore to indicate to an engineer what my hardened unit weight needs to be and what that tolerance is, because I actually have 5% from that 119, which is, 113 to 125 pounds, and average about 600 inches an hour on the infiltration. When it comes to maintenance, this is wrapping it up with my last slide here, one of my last slides on the maintenance. One of the biggest drawbacks to any permeable pavement is these owners don't have a maintenance plan. I've got about 12 specified projects here in the Lincoln and Omaha area. Not one owner has the equipment to maintain their pavements. That's a problem, or it's going to be a problem if we don't try to adhere to maintaining these, or at least communicating to the owners that it's time to maintain these parking lots. The equipment is starting to emerge. This is called the Bird Vac. For those of you who don't know, my nickname is Bird, and when Dave Mitchell called me up and said, "Hey, I got a new maintenance machine," we called it the Bird Vac. I was just tickled pink that he named it after me. Then I soon realized Bird stood for Bunion Infiltration Restoration Device, and I soon felt pretty silly over the deal. But when it comes to maintenance, there is a maintenance to this permeable pavements. We got to figure out what it is and some of the best equipment to use. I've used pressure washers that worked really well and revived them like they're brand new. The question is, how many times can I do that before it's not infiltrating at all? Is it 10 years down the line? Is it 20 years down the line? That's just some information that we're just going to have to share here as time goes forward. And of course, I always got to show this Memorial Stadium picture. I'm a big Husker fan. There's a big sign that says destiny is not a matter of chance, it's a matter of choice. And of course, I always look at it as density is not a matter of chance. It is definitely a matter of choice. And here in Nebraska, we are proving that by predicting in-place void content by utilizing that fresh unit weight. Now, I know that's a lot to take in, especially from a contractor's point. A lot of that density stuff I know you'd probably like to push off onto the producers. But as contractors, I think you guys really need to understand what you need to accept and what you need to reject. Because with this new type of a product, it's important that we protect it. And we do everything that we can to collect data to make us have better decisions in the future. So with that being said, I think we'll open it up. I got one question on here that somebody had asked. Is pervious concrete feasible in a hot, dusty, windy desert climate, such as New Mexico? Because the more constant upkeep, sweeping, vacuuming, and pressure washing, and I agree. I'll give you an example. We've got here in Nebraska, we've got a 4-foot strip of pervious concrete down the middle of a 50,000 square foot parking lot. And that brings in a lot of contaminants, a lot of fines into that. And I just call it a high maintenance design. And I think depending on where you're at, how dusty is it, I don't know if I can really answer that question, but maybe it's just more of a higher maintenance type of a pavement. But I do got a connection down there in New Mexico, and I know they use Pervious, so I guess I don't know if I can answer that question too much more. So is there any way we can go live with the calls?
Certainly. And as a reminder, you may submit an online question using the Q&A feature on your web console. If you'd like to ask a question over the phone, please press star then 1 on your touch-tone phone. If you wish to be removed from the queue, please press the pound sign or the hash key. There will be a delay before the first question is announced. If you're using a speakerphone, you may need to pick up the handset first before pressing the numbers. Once again, if you have a question, please press star then 1 on your touch-tone phone.
Oh, come on. All that work and nobody's got anything else? Hey, Steve's got a question up here he typed in. Have I ever tried to make test cylinders or cubes? I have never tried to make cubes. I have tried to make test cylinders. But again, when you're making, there is actually no ASTM standard to make a pervious concrete cylinder. Not like you can with conventional where you go, 2 or 3 lifts and so many rods per lift, 25 rods per lift, and you can't do that with pervious concrete because there is no standardized testing. But I have made cylinders for samples and to run my own tests on them. I'm not quite sure if I can use those in any kind of data, but I believe there's probably going to be something coming out. I don't know about soon, but I'm sure there'll be something coming out on how to make a cylinder in the field for pervious concrete in the future. But we don't use strength for acceptance, so I'm not sure what we would do with that information. I hope that answered your question, Steve. Anybody else?
And as a reminder, that's star then 1 to ask your question.
Man, this is just going to be too easy. Too easy. Brian Luty, I see you on the screen. You don't got nothing for me? All right. Well, if there is no any more questions, I do have one more slide I'd like to share. First of all, for those of you on Twitter, it's probably my favorite social media. I think it's because I can hide behind a cartoon character. But if you're on Twitter, follow me on Any Concrete for any more updates, anything I have new, any information, any news, any events. I always try to put it out on that Twitter feed. Also, we started up something new called Concrete Garb, which is a podcast dedicated to promoting people in the concrete construction industry, not necessarily promoting concrete. Although we do talk a lot about concrete, my job is to get people on this podcast and interview them to make concrete sexy and attractive and try to recruit people in high school that want to learn a skilled trade and just make it more attractive is what we're trying to do. So if you're passionate about concrete, get on concretegarb.com and or if you're on iTunes or on Stitcher, search for Concrete Garb and listen to some of these podcasts. We're just a couple of amateurs out there trying to get our word out and spread the word of local success stories of these guys in construction. But check it out. And last but not least, big shout out to Nebraska Concrete and Aggregates Association. Without the support of my members and allowing me to spend time and my resources to learn about Pervious concrete and to share that information with people like you, it's just heads and tails over the rest. These members I have are the best. So I want to give them a nice little shout out. So Brian Ludy popped something up there. He's technically stunned, he said. So Brian, you just call me if you got any questions. You got my number. So anything else? Anything? All right. ASCC, Shreya, you got anything? Or am I just left here hanging?
And at this time, we have no questions.
All right. Well, that concludes this portion of the webinar. I appreciate everybody taking the time to sit down and listen to me ramble. Again, if you have anything, any questions, Google my name on the internet, because if you're trying to find me and you can't get a hold of me, you are not looking. So with that being said, I hope everybody enjoys their afternoons. Have a great July. Enjoy the summer and stay busy. Thank you.
Thank you, ladies and gentlemen. This concludes today's conference. Thank you for participating. You may now disconnect.